USS Zumwalt DDG-1000 remains one of the most futuristic and technologically advanced destroyers ever built, and in 2026 it continues to represent the cutting edge of modern naval warfare. Unlike traditional warships that rely on conventional designs, the Zumwalt was created to challenge the limits of stealth, automation, and multi-mission capability. At first glance, its angular shape immediately sets it apart from every other destroyer sailing the world's oceans. The ship's unique tumble-home hull, sharply sloped surfaces, and enclosed deckhouse dramatically reduce its radar signature, making it appear much smaller on enemy radar than its actual size. This stealth-focused design allows the destroyer to operate closer to hostile coastlines while remaining more difficult to detect, giving naval commanders a significant tactical advantage during high-risk missions. Although the Zumwalt program originally envisioned a much larger fleet, the 3 ships that were ultimately built have become valuable platforms for advanced technologies and future weapons development. Stretching nearly 610 feet in length and displacing around 16,000 tons when fully loaded, the USS Zumwalt is considerably larger than most destroyers currently serving around the world. Despite its impressive size, the ship requires a surprisingly small crew thanks to its extensive automation systems. Sophisticated computer-controlled engineering systems, automated damage control equipment, and advanced monitoring technologies allow the vessel to operate efficiently with roughly half the crew needed by many comparable warships. Fewer sailors on board means reduced operating costs, improved living conditions, and more space for advanced mission equipment. Inside the ship, sailors benefit from modern accommodations, digital workstations, and integrated control centers that improve coordination during complex operations while reducing fatigue during extended deployments. Powering this remarkable destroyer is one of the most advanced propulsion systems ever installed on a naval vessel. Instead of using traditional mechanical drive systems, the Zumwalt employs an integrated power system that generates electricity for both propulsion and onboard combat systems. Powerful gas turbines produce electrical power that drives electric motors connected to the propellers while simultaneously supplying energy to sensors, communications equipment, and future high-energy weapons. This flexible power architecture not only improves efficiency but also prepares the ship for next-generation technologies such as laser weapons, electromagnetic railguns, and other energy-intensive systems that could become operational in the future. The destroyer's electric propulsion also contributes to quieter operation, reducing acoustic signatures that enemy submarines could detect underwater. Performance is another area where the USS Zumwalt continues to impress. Despite weighing thousands of tons, the destroyer can achieve speeds exceeding 30 knots while maintaining exceptional stability in rough seas. Its advanced hull design enhances seaworthiness, allowing it to operate effectively in challenging ocean conditions across the globe. Combined with an impressive operational range and long endurance at sea, the Zumwalt can participate in extended deployments without requiring frequent logistical support. Whether conducting patrols, escorting carrier strike groups, gathering intelligence, or responding to emerging international crises, the destroyer possesses the endurance and flexibility needed for modern naval operations. The heart of the USS Zumwalt lies in its advanced combat management system, where powerful computers continuously process information gathered from multiple sensors across the ship. Modern radar systems provide exceptional target detection, tracking, and engagement capabilities against aircraft, missiles, surface ships, and other potential threats. Advanced sonar systems enable submarine detection while electronic warfare equipment monitors hostile radar emissions and communication signals across the surrounding battlespace. Every sensor works together through integrated software that rapidly analyzes incoming data and presents commanders with a comprehensive picture of the operational environment. This high level of information fusion enables faster decision-making during rapidly changing combat situations where every second matters. The ship's missile armament makes it one of the most formidable surface combatants ever built. Distributed around the outer edges of the hull are 80 advanced vertical launch cells capable of carrying a wide variety of guided missiles. Depending on mission requirements, these launchers can deploy long-range land attack cruise missiles, anti-air missiles for fleet defense, anti-submarine rockets, and other specialized weapons. This modular approach allows naval planners to tailor the destroyer's loadout for different missions ranging from regional deterrence to full-scale combat operations. The distributed placement of these launch cells also improves survivability by reducing the likelihood that a single enemy strike could disable the ship's entire missile inventory. One of the most talked about features of the Zumwalt was its pair of advanced gun systems, originally developed to deliver precise long-range naval fire support for troops operating near coastlines. Although the specialized ammunition program was eventually cancelled due to extremely high costs, these gun systems demonstrated the ship's innovative engineering philosophy. In recent years, the United States Navy has shifted the Zumwalt toward a new mission focused on long-range precision strike capabilities. Planned upgrades include integrating advanced hypersonic missile systems capable of traveling at extraordinary speeds while maneuvering unpredictably toward heavily defended targets. These weapons could dramatically increase the destroyer's ability to engage strategic objectives from great distances while remaining outside many enemy defensive systems. Survivability has always been a major design priority for the USS Zumwalt. Beyond its low radar signature, the ship incorporates numerous features that improve its ability to withstand combat damage. Critical systems are distributed throughout the vessel to reduce the risk of catastrophic failure if one section is hit. Fire suppression systems automatically detect and respond to onboard emergencies, while advanced damage control technologies help isolate flooding, electrical failures, and structural damage. The ship's design also minimizes infrared emissions, making it more difficult for heat-seeking weapons to lock onto the vessel. Combined with electronic warfare systems capable of jamming enemy sensors and deploying decoys, these defensive measures create multiple layers of protection during high-threat operations. Aviation capability significantly expands the destroyer's operational flexibility. The large flight deck and spacious hangar can accommodate multiple naval helicopters, including the MH-60R Seahawk, as well as unmanned aerial systems that support surveillance, reconnaissance, search and rescue, logistics, and anti-submarine warfare. Helicopters extend the ship's sensor range far beyond the horizon while providing rapid response options during emergencies or combat missions. As unmanned aviation technology continues to advance, the Zumwalt is expected to play an increasingly important role in integrating drones into future naval operations, creating a networked force capable of monitoring enormous maritime regions with unprecedented efficiency. Communication and networking capabilities are equally impressive. The USS Zumwalt is designed to share information seamlessly with aircraft, satellites, submarines, allied warships, and joint military forces operating across multiple domains. Secure high-speed data links enable commanders to exchange real-time intelligence, coordinate missile strikes, monitor enemy movements, and maintain situational awareness across vast operational areas. This connectivity transforms the destroyer from a standalone warship into a central node within a much larger combat network, allowing coordinated operations involving multiple military branches and allied nations. Life aboard the Zumwalt reflects its modern engineering philosophy. Advanced automation reduces repetitive manual tasks, allowing sailors to focus on mission planning, system management, and operational readiness. Living spaces are designed to provide greater comfort during long deployments, while computerized maintenance systems continuously monitor equipment health and predict potential mechanical issues before they become major problems. This predictive maintenance approach improves reliability, reduces repair costs, and maximizes the ship's availability for operational assignments. Looking toward the future, the USS Zumwalt represents much more than a single destroyer